Good evening everyone, good evening. Good evening, I welcome you all again to JEE Enthuse. I hope all of you are doing great. So people, just let me know quickly in the chats if I'm perfectly audible and visible to everyone. Hello Munir, hello Tomsman, hi Aisha, hello Ashwa, hi Sana, hello Manisha, hello Nandini, hi Sham. Welcome back everyone, welcome back. Just give me some quick signal from the chat so that I'll get to know that I'm perfectly audible and visible to everyone. Hi Sai Rutvik, hi Yuvashri, hello Manaswi, hello Arshid. Welcome people, welcome. Just give me a second. Perfect guys, so as you all must be knowing, tonight it's going to be the sprint session from the chapter atomic structure, and in the tonight's session I have come up with around 30 questions. Let's try to solve these 30 questions and let's try to master certain concepts from the chapter atomic structure. Yeah? Perfect. So people, before starting the session, the ones who have just joined in, the ones who are new to the channel, let me quickly introduce myself. So my name is Wassim and I'm your chemistry master teacher right here on this JEE Enthuse channel, right? The ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this JEE Enthuse channel, right? So do like the video, share the video with your friends, and do subscribe to the channel as well, okay? So you guys can first of all let me know in the chats if all of you are super duper excited about the tonight's session, my dear people. Yes? Let me know fast in the chats if all of you are super duper excited about the tonight's session. Is the Josh high? Yes? Thank you Abhishek, thank you. Alright people, alright, wonderful. So let's get going then. Let's get started with the first question which is on your screen from the Rutherford's alpha particle scattering experiment. What do you think is going to be the correct answer of this particular question? Rutherford's alpha particle scattering experiment eventually concluded that mass and energy are related. It has got nothing to do with the Rutherford's experiment. Neutrons are buried deep in the nucleus. No. Electrons occupy space around the nucleus. What do you think about the option C, my dear people? What do you think about the option C? What do you think about the option C? Well, your Rutherford's alpha particle scattering experiment, it actually gave the idea about the electrons occupying the space around the nucleus, right? Option C is absolutely the correct answer of this particular question, right? A very simple and basic question. The point of impact with the matter can be precisely determined? No, nothing to do with this, right? So option C is the one which is basically going to be the correct answer of this particular question. Look at this question, people. The energies E1 and E2 of two radiations are 25 electron volts and 50 electron volts respectively. The relation between their wavelengths lambda 1 and lambda 2 will be. A simple question, and this question was asked in last year's JEE Mains examination. See what kind of a basic question was asked, people. Okay. Well, as you all must be knowing, first of all, okay, the energies E1 and E2 of two radiations, right, of two radiations are 25 electron volts and 50 electron volts. You guys will be knowing E is nothing, energy is equal to hc divided by lambda. You guys will be knowing, or you can say energy of the radiation is inversely proportional to its wavelength, right? Can I simply say E1 divided by E2, right? Can I say E1 divided by E2 will be simply equal to lambda 2 divided by lambda 1? Yeah? Perfect. Now E1 value is given to me as 25, E2 is 50. So E1 is 25 and E2 is 50 electron volts is equal to lambda 2 divided by lambda 1. The relation between their wavelengths, that is lambda 1 and lambda 2. The relation between their wavelengths, right? You need to see the relation between wavelengths. So this is 1, this is 2. So lambda 2, sorry, this is 1, right? So lambda 1 is equal to 2 times lambda 2, right? Lambda 1 is equal to 2 times lambda 2. Isn't it option C, guys? Right? A very simple and basic question. Yeah? A very simple and basic question. You know, energy of the radiation is inversely proportional to the wavelength of it, right? So you can just take the ratio of the E1 and E2. So E1 by E2 will be equal to lambda 2 by lambda 1. E1, E2 is given, so you are simply getting the relation between lambda and lambda 2, right? A very simple and basic question this is. I'm sure you can easily kill these sort of questions, right? This is something which you were supposed to do on your own. Anyways, I showed it. Have a look. A photon of light of wavelength of wavelength 6000 angstroms. We have got a photon, right, whose wavelength is 6000 angstroms, has the energy E. So this photon has got the energy E, right? What will be the wavelength of the photon of light which has got the energy of photon as 4e? For example, E1 is equal to E, I need to see, right? E2, which is basically equal to 4 times E, right? So again, the similar sort of question, people. Again, the similar sort of question. Let's call this as lambda 1. I need to calculate basically the lambda 2 value, right? Again, I'll be using the same relation. Let's say E2 divided by E1 right now I'm using. It's going to be simply equal to lambda 1 divided by lambda 2, right? Okay, so E2 divided by E1. Basically, this E is equal to E1, right? So E2 divided by E1 is 4. So 4 is equal to lambda 1 divided by lambda 2. I need to calculate the value of lambda 2, which will come out to be lambda 1 by 4. Lambda 1 is 6000 divided by 4. This is going to be the angstroms, right? This is the final answer. So final answer will come out to be, it's going to be 1500 angstroms. So option A is the one which is the perfect correct answer of this particular question as well. I'm sure you have solved it already, right? Moving on to one more question, guys. Calculate the energy of 100 photons. Again, the simple question. You need to calculate the energy of 100 photons in joules if the wavelength of light is 2000 angstrom. You must have studied about this relation, right? E is equal to NhC divided by lambda, right? Energy possessed by n photons, right? So people, we need to calculate the energy possessed by how many photons? 100 photons. So n value is 100. H value you guys will be knowing 6.6 into 10 raised power minus 34. C value is simply going to be 3 into 10 raised power 8, right? Divided by lambda. Lambda value is given to me in angstroms. So I'll be converting it into what? 2000 angstroms, right? Into 10 raised to the power minus 10, right? Now it's going to be in meters. Perfect. Or you can do a bit of less calculation like this. See, n value it's equal to 100. Hc value I'll be using as 12400 electron volts, right? Electron volt angstroms, right? Divided by lambda. Lambda is simply equal to 2000 angstroms, right? So this got cancelled. So the final answer is coming out to be electron volts, right? So this double zero got cancelled. This zero got cancelled. It is 21. It is 2620. So E value is coming out to be simply 620 electron volts. But do I need to calculate the energy of these 100 photons in electron volts? No. I need to calculate the energy in joules. And you guys have been knowing 1 electron volt is nothing. 1 electron volt is equal to 1.6 into 10 raised to the power minus 19 joules. Just solve it, get the answer. That's all. You all must be familiar with the fact H into C value, it's always equal to 12400 electron volt angstrom, or you can say 1240 electron volt nanometer, right? Yes. So finally, the answer comes out to be 9.9 into 10 raised power minus 17 joules, right? This is the energy carried by 100 photons in joules, which I was supposed to calculate. Yeah? Right, people? Let's move on to one more. Look at this particular question. This question is calculate the number of photons of light required to this. This question is basically based on your photo dissociation. See what the question says exactly. See guys, calculate the number of photons of light having wavelength this much required to dissociate 1 mole of Cl2. So basically, I'm dissociating 1 mole of Cl2. I need to dissociate, I need to break 1 mole of Cl2. I need to break 1 mole of Cl2 into its atoms, right? If the bond energy of Cl-Cl bond is 1.2 kilojoules per mole, right? If the bond energy of Cl-Cl bond is 1.2 kilojoules per mole, what does that mean exactly? That means in order to break 1 mole of bonds, how much energy is needed? In order to break 1 mole of bonds, how much energy is needed? 1.2 into 10 raised power 3 joules, right? In order to break 1 mole of bonds, this much energy is needed, right? Now, 1 mole of bonds will be containing these many number of bonds. So in order to break NA number of bonds, how much energy is needed? 1.2 into 10 raised power 3 joules. So can I say, what do I need to say exactly? Calculate the number of photons required to dissociate 1 mole of Cl2. Okay. So basically, in order to break 1 mole of bonds, this much amount of energy is needed. Let's say this much of amount of energy I'm giving in the form of photons. Let's say this much amount of energy I'm providing to Cl2 in the form of photons, right? So I'll be just using one equation. Let's assume there were some n photons right, of wavelength 2000 angstroms, which carried this much of energy, then only I can say 1 mole of bonds will get broken down. So this is something which I'll be equating to 1.2 into 10 raised power 3, right? Okay, what do I need to calculate? I need to calculate the value of n. H value, Planck's constant, 6.6 into 10 raised power minus 34, 3 into 10 raised power 8. Lambda value is going to be what? It's going to be 2000 into 10 raised power minus 10 meters, right? This term is already in joules. From here you can easily calculate the value of n, right people? So finally, let me show you the final answer. After solving this equation, you get the final answer as this much. These many photons of wavelength 2000 angstroms you need in order to break 1 mole of Cl2 into these Cl atoms. I'm sure the concept is clear to everyone. Yeah? Perfect? Right people? I'm sure. See, this much amount of energy is needed to break 1 mole of bonds, right? And this amount of energy you are providing in the form of photons. Let's say there were some n photons which carried this much of energy, right? So I'm just equating the energy of n photons of wavelength 2000 angstroms to this much amount, right? So from there, you can calculate easily the value of n, right? That's something which I was supposed to calculate. Moving on to one more. Look at this question carefully, guys. What the question says, the de Broglie's wavelength, lambda associated with the photoelectron, varies with the frequency of the incident light as V0 is the threshold frequency. Okay. See, it's again a simpler one. I'm sure you all must have heard about this relation. Lambda is equal to h upon under root of 2m kinetic energy. Right? Right, people? You all must have heard about this relation. Perfect. Now there is one more relation, the photoelectric equation, which you would have studied, I'm sure. H nu is equal to h nu naught plus maximum kinetic energy, Ke maximum, right? So from here, can I calculate Ke? So kinetic energy maximum is going to be h nu minus h nu naught, right? So just put this kinetic energy term into this equation. So you get lambda is equal to h upon under root of 2m multiplied by. Instead of kinetic energy, you can write h nu minus h nu naught, right? What was I supposed to check? Lambda, how it varies with these terms. See, how lambda is varying with mu minus mu naught. How lambda is varying with mu minus mu naught. I can say lambda is inversely proportional to mu minus mu naught raised to the power 1 by 2, right? So what is the correct answer of this particular equation? It's going to be option D, right? Isn't it simple again, my dear people? Isn't it simple again? Right? So it's basically going to be option D, which is going to be the correct answer of this particular equation, right? Yeah? Okay, let's move on to one more. This is one more question, a very simple and basic one. See guys, you will be knowing how to calculate the radius of the nth Bohr's orbit, right? There's a formula for it. Radius of the nth Bohr's orbit is simply equal to r naught n square divided by z, right? This is something every one of you would be knowing. Calculate the radius ratio of second orbit of HE positive and third orbit of BE positive, right? So I'll be writing something like this. Radius of second orbit of HE positive divided by radius of third orbit of BE positive will be simply equal to n2 square divided by n3 square multiplied by z3 divided by z2. This is how I'll be writing it simply. Okay. What do I need to calculate? I need to calculate this ratio. The ratio of second orbit of HE positive and third orbit of what? BE tripositive. For HE positive, what is the value of Z? Z value for helium is 2, right? If I talk about the Z value for beryllium, it's 4. You guys have been knowing, right? So I can say R2 divided by R3. This ratio is something which I need to calculate. N2. N2 means the second orbit, right? 2 ka square comes out to be 4. 2 ka square comes out to be 4. Divided by N3. That means this third orbit, 3 ka square comes out to be 9. Multiplied by Z3. Means atomic number of this B tripositive, which is 4, divided by Z2, which is the atomic number of helium, which is 2, right? So the value comes out to be 16 divided by 18, right? You can further solve it. It's going to be 8:9. So 8:9 is going to be the correct answer of this particular equation as well, which is option A, right people? I'm sure this again clear to every single guy. Yeah? Simple, I'm using this relation, right? I'm taking the ratio of the radii. That's all. That's all I did. Moving on to one more particular question. Look at this. Again, the simple one, based on the velocity, right? Velocity of the electron is given by the formula. Velocity of the electron in the nth orbit is equal to V0 multiplied by Z upon N, as you all must be knowing, right? If the velocity of the electron in the first orbit of hydrogen is V, so velocity of the electron in the first orbit of hydrogen is V. Perfect. what will be the velocity v2 of the electron in the third orbit of Li positive? Okay, that's something which I need to calculate, right? So if the velocity v1 value is equal to v, I need to calculate v2 value exactly, right? So basically I'll be again taking the ratio. I'll say v2 divided by v1 will be equal to z2 divided by z1 multiplied by n1 divided by n2, right? v2 is something which I need to calculate. v1 is equal to v, right? So it's basically v2 divided by v1. v1 is v divided by is equal to z2. Z2 is basically the atomic number of Li di-positive, hydrogen, lithium, that's 3, divided by Z1, that's atomic number of hydrogen, that's 1, multiplied by N1. N1, the velocity of the electron in the first Bohr's orbit, N1 value is 1, and what about N2? That means N2. What will be the velocity of the electron in the third Bohr's orbit? So N2 value is 3. 3 gets cancelled out. So V2 value is coming out to be simply V, right? That's all. Option B is the one which is correct, right? I'm sure it's again clear to everyone. Right, people? A very simple one again. Look at the next one. Again, the similar sort of question. If the speed of the electron in the first Bohr's orbit of hydrogen be x, so the speed of electron in the first Bohr's orbit of hydrogen is x, right? The speed of the electron in the third Bohr orbit. I need to calculate the speed of the electron in the third Bohr's orbit, right? So simply, you know, velocity of electron in the nth Bohr's orbit is nothing that is v0 multiplied by z upon n. This is the formula which we use, right? Now, first thing, I will be writing something like this. V1 divided by this V3 is equal. It's going to be Z1 divided by Z3 multiplied by N3 divided by N1. Perfect? Yeah. V1 value is equal to X. So V1 value is X. V3 I need to calculate is equal to Z1. If the speed of the electron in the Bohr's first orbit, right? In the Bohr's first orbit, right? So first of all, for hydrogen, Z1 value, Z is equal to 1, atomic number is 1. Z3 is the atomic number of what? It is the atomic number of hydrogen only, right? So it's 1. So let's neglect Z1 and Z3 as well. Let's make it only as N3 divided by N1. N3 is just going to be 3. N1 is just going to be 1. Perfect? So it's done and dusted. So V3 is coming out to be x by 3. X by 3 is option B, which is the correct answer of this question as well, right? I'm sure you can solve these simple questions, right? Just need to take the ratios, that's all. Which of the following series of transitions in the spectrum of hydrogen falls invisible, right? Lyman, Balmer, Paschen, bracket. Just remember it like this, UV, III, UV, III, right? Lyman series falls in ultraviolet, right? Balmer falls in visible, Paschen falls in infrared, bracket falls in infrared, and Fund also falls in infrared, right? So it's basically going to be the Balmer series which falls in the visible region. Ultraviolet, this one ultraviolet, visible, infrared, and Fund also falls in infrared, right? Do remember this one as well. Absolutely, guys, you all are perfectly right. Moving on to one more. Look at this particular question and let me know its answer in the chats. When an electron is excited from ground level to fifth orbit, the maximum number of spectral lines obtained in the Bohr spectrum of hydrogen. How do we calculate the maximum number of spectral lines? N into n minus 1 divided by 2, right? When the ground state is, when the electron makes a transit from ground state, right? Perfect. So basically, n value is 5. So 5 into 5 minus 1 simply divided by 2. The value comes out to be 10. So these many spectral lines will be obtained, right? So it's 10. I'm sure it's clear. Right, people? Let's move on to one more then. The wavelength of the radiation emitted when the electron falls from infinity to stationary state 1. So electron is making a transition from infinity to shell number 1, right? Would be. So basically, N2 value, higher energy state is given to us infinity, N1 value is equal to 1, right? So what do we need to calculate? Wavelength. 1 divided by lambda is equal to Rydberg's formula, R Z square. Since we are talking about hydrogen, for hydrogen Z is equal to 1. 1 upon N1 square minus 1 upon N2 square. You would have seen this particular formula, right? So it's going to be 1 divided by lambda is equal to R. 1 upon N1 square. That's going to be 1 upon 1. Minus 1 upon infinity is going to be 0. So nothing to do with that. If I take reciprocal, lambda is going to be 1 divided by R. And do remember from now onwards, 1 divided by R is equal to 911.5 angstroms, right? But the answer is given in nanometers. So it will come out to be 91 nanometers, right? 91 nanometers is going to be the final answer of the question. So it's option C, which is going to be the correct answer. If you talk about this particular question, you can easily solve this one as well, I'm sure. See guys, the wavelength in centimeters of second line of Lyman series. If you talk about the second line of Lyman series, in the second line of Lyman series, the electron makes a transition from 3 to 1, right? So this is basically the value of N2. and this is the value of N1. Yeah, N2, N1. Perfect. Now we use the Rydberg's formula. What do I need to calculate? Wavelength. So 1 divided by lambda is equal to R. For hydrogen, Z is equal to 1. 1 upon N1 square minus 1 upon N2 square, right? So 1 divided by lambda is going to be R multiplied by 9 minus 1, that's 8 divided by 9, right? So lambda value from here comes out to be 9 divided by 8, 9 divided by 8R. This is the value of lambda, 9 divided by 8R. So option B is the one which is correct. Yeah, very simple and basic questions, people. Okay, moving on to one more then. The electrons are more likely to found in which region? See, it is psi versus x curve, right? See, at this point psi value is becoming 0. That means at this point it's representing a node where the electron density will be 0, right? So where will be the electron density maximum? In A and C region, right? So in A and C region, in the region A and C, the electron density is going to be maximum, right? Because this point, it represents your node. Yeah? Absolutely, Harika, you're right. What about this one, guys? What the equation says? It's a simpler one, guys. Again, de Broglie's wavelength, right? Formula based lambda is equal to h upon mv, right? Lambda is equal to h upon mv, but make sure all the parameters are used as per the SI system, right? That's all. This is something which you will do on your own. I'm not going to solve this, right? It is simple. Mass is given to me as 1000 kilograms, right? Velocity is given to me as 36 km per hour. Just convert it into meter per second, right? Then use lambda is equal to h upon mv. That's all. I'm not going to solve this particular one. Okay. Look at this question. A stream of electrons from a heated filament was passed between two charged plates kept at potential difference V. If E and M are the charge and mass of the electron respectively, then the value of h upon lambda. See, guys, it's a simple equation. Few minutes back only I gave you one relation. For the electron, lambda is equal to h upon under root of 2m multiplied by Ke, kinetic energy, right? This is the relation which I gave you a few minutes back for the electron. What do I need to calculate? This is simple, guys. I need to calculate h upon lambda, right? I need to calculate h upon lambda. Can I say h upon lambda is equal to under root of 2m multiplied by Ke? Instead of Ke, you can write EV as well, right? Instead of Ke, you can write EV as well. So what is the final answer? The final answer is going to be option C, right? Instead of Ke, you can write EV, potential energy as well. Yeah? One more, guys. The electrons identified by the quantum numbers n and l. The electrons identified by the quantum numbers n and l, okay? The correct order of their increasing energies. How do I arrange them on the basis of their increasing energies? By using Bohr-Bury's rule, n plus l. N plus l value for this is 5. N plus l is 4. N plus l is 5. N plus l is 4, right? Yes. Now among second and fourth, where since n plus l value is same, so decide on the basis of n. N value is least for this one, so fourth one will be having the minimum energy. Fourth one will be having the minimum energy, followed by second one, and then comes your first and third, right? Among first and third, again your n plus l value is same, so decide on the basis of n, where the n is least, energy is least, so third will be having less, then comes your first. So first is going to have highest energy. So this is going to be the energy order, right? 1, 3, 2, 4. 1, 3, 2, 4. So it's option C, which is basically going to be the correct answer of this particular question as well. Yeah, I'm sure you guys have solved it properly. The number of nodal planes in px, right? Again, the simple question, guys. If you talk about the px orbital, let's assume this is your x-axis. Let's assume this is the x-axis, right? This is basically your px orbital, right? How many nodal plane? So basically, if I talk about this particular nodal plane in yz, right? This is basically one of the nodal planes over here, right? In which the electron density is going to be 0, right? Basically, there is a plane cutting this orbital in such a way that on this plane, there will be no electron density, and that plane is the nodal plane. So there is one nodal plane in case of what? In case of px orbital. Perfect, right? And this nodal plane, it lies in yz plane. It lies in yz plane. Yeah? Perfect. Okay, the correct set of 4 quantum numbers for the valence electrons of rubidium. If you talk about rubidium, whose atomic number is 36, what is going to be its configuration? Outermost configuration. If you talk about the outermost configuration of rubidium, it's going to be krypton, then comes 5s1, right? It's a group first element. Okay, so for the outermost electron of rubidium, you need to find its quantum numbers. N value is 5, N value is 5, right? Electron is present in S subshell, so L value is 0. If L is 0, M is equal to 0, right? And then it's going to be either plus 1 by 2 or minus 1 by 2. So which option satisfied it? 5, 0, 0 plus 1 by 2. It's option C, which is the correct answer of this particular question as well. Yeah? Right, people? Again simple. You guys know L value, it is from 0 to n minus 1. N value is from minus L to plus L. That's something every one of you will be knowing. Anyways, moving on to one more. The number of radial nodes in 3s and 2p. The number of radial nodes in 3s and 2p. I think the session is going to end fast. I don't know why. The number of radial nodes at 3s and 2p. So first of all, if you talk about the angular nodes is given by the value of L, and your radial nodes is given by the value of n minus L minus 1. I need to calculate the radial nodes, right? So for 3s, what is the value of n? N value is 3. What is the value of L for 3s? It's going to be 0, right? Similarly, if you got to know the n and L values, just calculate the radial nodes for 3s. So radial nodes for 3s is going to be n value is 3 minus L value is 0, this minus 1, so the value comes out to be 2. So radial nodes in case of 3s are going to be 2, right? What about 2p? What about 2p? For 2p, n value is equal to 2, L value is equal to 1, so n minus L minus 1. n minus L minus 1, the value comes out to be 0. So there is 0 radial nodes in 2p, right? So 2, 0 is going to be the final answer. So it's absolutely option A, which is the correct answer of this particular question as well. Yeah? Simple? Simple, guys? Moving on to one more. A certain orbital has no angular nodes. A certain orbital has no angular nodes. That means the L value will be equal to 0, right? Because angular nodes are given by the value of L, and two radial nodes. Radial nodes are given by the formula n minus L minus 1, right? And there are two radial nodes. Since this value is 0, so n minus 1 value is equal to 2. So n is equal to 3, right? So n is 3, L is 0. L is 0 for S subshell. So it's basically talking about 3s, right? So 3s is going to be the correct answer of this question. Yeah? Again simple. Okay, which of the following is not possible for 4p or 3d? Either of the two. Which of the following is not possible for 4p or 3d? N value is 3, L value is 2, that means D, right? M value plus 1, S value plus 1 by 2. So this one is valid for what? It's valid for 3D. It cannot be our answer, right? 4, L value is 1, L value 1 means P, so 4P, right? And M is 0, S is plus 1 by 2, this one is valid for 4P. 3 and 3, can L value be equal to N? L value cannot be equal to N. That's something which you all must be doing. L value cannot be equal to N. L value is always less than N, right? Because L is equal to 0 to N minus 1. Perfect. So this one is not representing either your 3D or 4P. So option C is the one which is going to be the answer of this particular question as well. I'm sure this is again killed by all of you. Let me move on to one more question, guys, then. Correct the following set of quantum numbers. Which of the following sets of quantum numbers is not possible? Which of the following sets of quantum numbers is not possible? First of all, you guys will be knowing L value is from 0 to N minus 1. M value is from minus L to plus L, right? See, N is equal to 3, perfect. L is equal to 0, perfect. M is equal to 0, perfect, perfect. So this is perfect. There is nothing bad in it, right? What do I need to select? See, which of the following sets of quantum numbers is not possible? First one is perfectly possible. In the second one, N and L are same, which cannot be possible because L will be always less than N. So this is not possible, first of all. This is 4, this is 3, this is minus 2, this is minus 1 by 2. It's perfectly correct. 1, right? Just a second, guys. Yeah, 1, 0, minus 1. See, L value is 0 and M is always from minus L to plus L, right? So M cannot be minus 1. So this also incorrect. 2, 3, L value is greater than 2. This also incorrect. So 2, 4 and 5 are incorrect ones. 2, 4 and 5. So it's option C which is the correct answer of this particular question as well. Yeah? Right, people? Let's move on then to one more question. According to Bohr's theory, the angular momentum of electron in fifth orbit. Can't you do it? In fifth orbit, nh upon 2 pi is the formula, right? nh upon 2 pi is the formula. In fifth orbit means n value is 5. So 5h upon 2 pi. So 2.5 h upon pi is the final answer. 2.5 h upon pi is the final answer, right? Isn't it simple, guys? The uncertainty involved in the measurement of velocity of an electron within a distance of 0.1 angstroms, right? So uncertainty in the distance delta x is given to be as 0.1 angstroms, which is going to be equal to 0.1 into 10 raised power minus 10 meters, right? Okay, so delta x is given to us. What do I need to calculate? Uncertainty in the measurement of velocity of the electron. For the electron, the mass will be taken as 9.11 into 10 raised power minus 31 kilograms. So I'll be using the Heisenberg's uncertainty principle. Delta x dot delta p is greater or equal. I'll be using the equal sign is equal to h upon 4 pi, right? I'm using the equality sign over here. So delta p, instead of delta p, you can write m delta v. right? It's equal to h upon 4 pi. What do I need to calculate? I need to calculate delta V. Uncertainty involved in the measurement of velocity. I need to calculate delta V. So delta V is equal to h upon 4 pi m multiplied by delta V. H value 6.6 in 10 is per minus 34, right? Pi value 3.14, m 9.11 in 10 is per minus 31. Delta V calculated in terms of meters. Put all the values into this expression, get the value of delta V. That's something which you are supposed to calculate. So delta V will be finally this much is the uncertainty in the velocity which I was supposed to calculate, right? Simple, the formula based one. Just you need to put the values, get the answer. That's it. What is the correct orbital designation of the electron? With the quantum numbers n is equal to 4, so it belongs to fourth shell. L represents the subshell. L is equal to 3 represents F subshell, right? So 4F, there is only one 4F, which is option B, which is going to be the correct answer of this particular question as well, right? Right, people? Okay, the plots of radial distribution functions for various orbitals of hydrogen atom against star are given below. The correct plot for 3s. If you talk about 3s, how many total nodes are there in 3s? This is the formula to calculate total nodes. 3 minus 1 comes out to be 2. So there are basically 2 nodes in 3s. So where do you see the 2 nodes? Where do you see the 2 nodes? Where do you see the 2 nodes? See guys, this is one particular node. This is one more node where the curve is touching the r-axis, right? These two represents the nodes basically. So it's option D where you can see where the curve shows there are 2 nodes. So option D is the one which is valid for 3s, right? Perfect. N minus 1, right? Total number of nodes in case of 3s is going to be n minus 1. So 3 minus 1 comes out to be 2. So there are 2 nodes which are shown by only fourth curve. So fourth is the one which is valid for exactly year 1. The graph between size square and distance. Okay, size square and distance. First of all, size square versus r. Size square versus r. So first of all, how many nodes are there? There is one node. There is one node, correct? There is one node. So basically, if I need to check, is this curve going to be for s orbitals or p orbitals? Is it going to be for s orbitals or p orbitals, right? Well, if you talk about the s orbitals, closer to the nucleus, electron density is maximum. Size square value is more. When you go closer to the nucleus, in case of s orbitals, size square value increases. So closer to the nucleus, size square value is maximum. Then when you move far, size square value decreases. Then comes a node, right? So this is basically valid for s. It is valid for s. It can be either 1s or 3s, right? In case of 3s, or it can be 2s. But how many nodes are there in total? Say in case of s, there is no angular node, right? L value is 0, there is no angular node. So there will be radial nodes only. So basically over here there is one node and there are basically one total nodes only. So n minus 1 value is equal to total number of nodes is equal to 1. So n value is equal to 2, right? So you got the principal quantum number and you already identified this is for s. So 2s is going to be the final answer. So option D is the one which is correct, right? Simple, guys. Yeah, I think we solved some 32 questions, right? Okay. Yes, we solved some 30 questions in just 34 minutes. How come it's possible? What did I do? I was supposed to solve it in 1 hour. Anyways, this was a very short and precise session, right? Okay, one more thing, guys. For the crash course, if you have not enrolled in the JEE 2022 crash course batch yet, do get enrolled in it as soon as possible. Perfect. The next crash course batch for JEE 2022 is starting on Monday, right? And right now there is EdFest going on currently in Vedantu, wherein on every course you are getting 50% off, and you are just getting enrolled in this batch only for 8K. You need to pay this much of amount only. That's all. Well, in this particular crash course batch, which is starting on Monday, your whole syllabus in physics, chemistry, mathematics will be done and dusted. Yes. And at the same time, no need to worry about the test series, no need to worry about the mocks. Every single thing will be provided to you. Study material, and at the same time, the best teachers of Vedantu will be training you in all the subjects, right? And it's completely affordable. If you use the coupon code WSPRO, right, or WBPRO, you'll be getting the crash course just for 8K. In 8K, your whole syllabus is getting dusted from exact scratch, right? From exact scratch, your whole syllabus will be getting complete in all the subjects. Apart from that, study material, that's one of the finest study material which you can ever come across, right? At the same time, study material, mock tests, test series. No need to buy the test series from some other source. You'll be getting the test series in this particular batch only, right? So all the things, whatever things are needed for the competitive examination like JEE to get cracked, all those things are involved in this particular crash course, right? Yeah. So do get enrolled in it. The batch is starting. The next batch is starting on coming Monday, right? On 14th of February. I'm erasing it, right? It's not 8th of February, it's 14th of February. Yeah? Right, people? And how to get enrolled into this crash course batch? Okay, by the way, as you all must be knowing, today, your CBSE, a notification came in which it was mentioned that CBSE Term 2 examinations are going to be held from 26th of April, right? So, for the particularly class 12 students, right, we have come up with a crash course for CBSE Term 2. You guys can enroll into it. Trust me, it's going to be highly beneficial for you. All the things in all the subjects will be covered through this particular crash course, right? Okay, and how to get enrolled in all these things? Have a look. This is the video which you guys are currently watching, right? You just need to drag the video a little down, click on show more. Over here, you'll be getting a lot of links. JEE crash course. For example, you are enrolling for a JEE crash course, click here. If you are enrolling for CBSE Term 2 full syllabus preparation, click here. The choice is all yours. For example, I'm clicking here on this link. I'm just dragging it a little down for the CBSE Term 2. Okay, you need to select your plan. Right now, as I told you, 50% off is going on, and you are just getting this crash course. Is this CBSE Term 2 crash course only for 4K? Yeah? Perfect. Right, people? So just you need to click on buy complete course, put your number, email ID and everything, on which you'll be getting the OTP and every single thing, and eventually you'll be getting enrolled in the CBSE Term 2 crash course batch. Yeah? Right, people? So with this, I'm going to take a leave. Well, Avani, I think there will be 2 or 2.5 months, it'll be done. Right? After two months, most probably, your JEE Mains is going to be there. Yeah? Perfect. That's great, Ajay. Welcome to the session. But you came late. Alright, guys. I'll see you guys tomorrow at the same time. Till then, you take care. Bye-bye. God bless you all. Love you all. See you. Take care. Bye-bye.